The coolest dinosaurs history forgot. Dinosaurs like T-rex and Triceratops were some of the largest and most charismatic animals we never knew, but they represent just a fraction of the animals that once were. From the moment organisms discovered that there was a benefit to having more than one cell, an evolutionary arms race began that continues to this day, producing novel and fascinating ways to outlast the competition. In today's video, we're exploring a selection of these incredible animals, from a half-billion-year-old shellfish to amphibians that can make a crocodile cry. Starting with the oldest and working our way through history, we'll show you that there was more of the prehistoric life forms than Jurassic Park's Big Five. To set the scene, let's go back to a land before time, and a time before land animals had even been invented, the Ordovician. The Ordovician was a primitive time for life on land. This was the period in which the first terrestrial plants were just getting a foothold on Earth, but life in the ocean had already been around for more than 3 billion years. For the majority of this time, life was all single-cellular, and nobody's quite sure when it made the shift. But at least 600 million years ago, multicellular life exploded onto the scene, and by around 540 million years ago, the so-called Cambrian explosion was in full swing. The Ordovician was the next time period, beginning around 480 million years ago, and by this time there was a multitude of complex life, but only in the oceans. Mollusks, who had for so long been moving around entirely defenseless, now had to grow shells to protect them from the novel concept called predation. And predators, too, needed to hide in ambush and defend against their own kind, so made the use of their own shells for this purpose. One such predator was Endoceras, an enormous cephalopod, and a relative of the modern nautilus. Endoceras didn't have a coiled shell, yet. These were really only just becoming a thing at this point. Instead, its shell was elongated, conical, and would extend away from the animal's head up to a possible 9 meters long. Endoceras lived roughly between 470 and 440 million years ago, during the Middle and Upper Ordovician period, and its fossils have been found all over the world, particularly in North America and Europe, as well as in Australia. These predators likely hunted by ambushing prey from the seafloor, hovering ominously in their vertical shelves until a victim was unlucky enough to walk beneath them. Unfortunately, they went extinct at the end of the period, as the Ordovician gave way to the Silurian, but there would be plenty of creatures to take its place, such as conodonts. Fossils of Cretaceous monsters like T-rex are some of the most recent dinosaur fossils around, and even these are hard to come by. In fact, there are only 30 or more so complete skeletons of these giants, and they lived only 66 million years from us. Conodonts, on the other hand, live much farther back, originating all the way back to the Cambrian, but really coming into their own during the Silurian. And these strange animals have left us with millions of fossils. But for decades, nobody really knew what these fossils were. For one thing, they were tiny. Most conodont fossils were between 1 and 5 millimeters long, and looked like rows of coned teeth, and this is where they got their name. Before anyone had figured out what all these little teeth may have belonged to, geologists had realized by identifying the differences in the fossils and correlating them to where in the strata of the Earth they were found, these could be used to identify and categorize different evolutionary periods. Conodonts existed 300 million years and were very widespread, making them ideal for identifying when periods ended and when others began. For example, the Ordovician and Silurian periods were clearly marked in the fossil record by species of conodont. This makes them some of the most significant animals to ever contribute to our understanding of the Paleozoic period. But what were they? Conodonts, despite the name, were jawless invertebrates, likely with eel-like bodies and large eyes. While the tooth-like fossils weren't truly teeth, it's thought that they were used to catch prey and may have been part of a venomous bite. The debate is ongoing about how these tooth-like elements function, but it has become clear that conodonts were some of the earliest and most successful vertebrates ever. So, conodonts are one of the reasons we know so much about when these other animals existed. And as we move into the Devonian period for our next animals, we can thank these little predators for showing us the way. Next up, the Devonian marks the point at which pioneering species finally took the leap into terrestrial ecosystems. Trigonotarbida was a whole order of some of these pioneers, and contained arachnids that we might recognize as early spiders or mites. These animals likely didn't produce silk like modern spiders, but would have been predatory stalkers of other arthropods, killing with switchblade-like mouthparts and clawed legs. It's not thought that these arachnids had venom, but their mouth parts suggest they ate liquid food, which meant they probably secreted some kind of digestive liquid into their prey before slurping them up. Yum! While the late Devonian land animals were pretty small, the waters were teeming with giants, and the armored fish known as Dunkleosteus was one of the most intimidating. Placoderms were a class of fish that didn't make it out of the Devonian, but would have caused all kinds of terror if they had. Dunkleosteus was just one genus of them, and grew upwards of 10 meters and 4 tons in weight. They had the highest bite force of any fish known, and one of the highest of any animal. They had mouths like a snapping turtle and the bladed jaws of a Bond villain, and would have patrolled the deep, dark ocean waters, ambushing prey with a snapping jaw that could open and close in 1/20th of a second. But as the conodonts show us, there was a sudden shift at the end of the Devonian that gave way to the Carboniferous period, and few animals survived this. Dunkleosteus was one of the casualties here, but the world of monsters on land was just getting started. Next up, Arthropleura of the Carboniferous period. By the Carboniferous, which began 345 million years ago, arthropods were really getting the hang of things on land. Millipedes and centipedes were two of the earliest successful land animals, and in the absence of anyone telling them otherwise, they both became quite large. Arthropleura may well have been the largest arthropod to ever existed, trundling along as it did, at an intimidating 2.5 meters long. This animal has left footprints in the dirt, frozen in time for hundreds of millions of years, preserving the ancient trackways of a giant millipede that had a leg span of up to 50 centimeters across. Arthropleura would have occupied the forest floor during the rise of the earliest forests, perhaps benefiting from more open habitats and swampy bogland where it could feed on decaying plant matter and rotting trees. This monsterpede went the way of almost everything else at the end of the Carboniferous, as another extinction event cleared the land of almost all life. But out of the ashes came the rise of the tetrapods. The Permian marks the period in which our fishy ancestors got bored of being chased by untold horrors and splashed their way into the muddy shores that gradually lessened their reliance on water and become terrestrial. On land, there were plenty of arthropods and plants to eat by now, but the fossil record shows that early tetrapods were just as interested in eating one another. The reptile line that would one day become the dinosaurs was not really well established at this point, but there were still some pretty intriguing predatory animals around. Dimetrodon was one of the coolest such reptiles, and it reigned from about 295 to 272 million years ago, long before the dinosaurs got their shot at the title. While this was a reptile, it was closer to the animals that would become mammals than it was to the dinosaur line, which makes it one of our ancestors, and back then we were scaly, had long, terrifying teeth, and an enormous sail on our backs. Dimetrodon was a member of some of the earliest large terrestrial carnivores. Its teeth were unquestionably for killing, and were serrated to that effect. This hunter would have grown around 5 meters long and sported some kind of spinal display, the role of which is uncertain. It was once thought that the sail could have aided in thermal regulation, catching the low sun's ray in the coolest part of the day and acting as a radiator during the warmest hours. But more modern hypotheses suggest that it was all for show, and would have been a great way to pick up a mate. Dimetrodon is probably the best well-known animal on this obscure list, but it can often be lumped in with the dinosaurs, despite going extinct over 40 million years ago before the dinosaurs showed up, and essentially being a prototype mammal. So all of these animals demonstrate that you don't have to be a dinosaur to be awesome. But we're coming into the first of the trilogy of the dinosaur periods as we enter the Triassic. By the time dinosaurs showed up, poor old Dimetrodon was almost as extinct as the dinosaurs are as us today. Next up, Metaposaurus. But while dinosaurs started to become important in the Triassic, they were far less from dominant, at least to begin with. The Triassic was still a time of giant carnivores, but a lot of these were still amphibians, and Metaposaurus was one of the largest. Even into the late Triassic, there were amphibians with large skulls, 100 teeth, a crocodile-like body form, a salamander-like tail, and beady, frog-like eyes. But this strange and, frankly, worrying mix of features came in a package that was 3 meters long and weighed more than half a ton. This was one creature you wouldn't want lurking in your pool, but being an amphibian, Metaposaurus was much more limited to the watery world of swamps and bogs than this next creature. And while the dinosaurs were still on the path to dominance, the phytosaurs maybe have been ancestral to some of the dinosaurs we see every day. Phytosaurs were early crocodilian-like predators found all over the world around the late Triassic. While they looked like a lot of crocs do today, there were some key differences. They had very heavy, bony armor, crested snouts, and nostrils that sat far closer to the eyes than we see in modern crocodilians. One of the later species of these monstrosities was Angistorhinus megalodon. If that name sounds familiar, it's the same species name as the enormous shark, and means big tooth. But Angistorhinus was the original megalodon, living some 300 million years before the shark did. And not only were its teeth big, but they were also serrated. It was also enormous, at up to 8 meters based on the fossil skulls found, heavily built, and bigger than any living crocodilian, and certainly would have been one of the largest of the phytosaurs. This animal evolved to feed on some of the crazy armored vertebrates that roamed the land at this time. And, unsurprisingly, they evolved that armor to improve their chances against predators like the phytosaurs. One of those armored animals was the Smatosuchus, who may have looked like a sort of wingless horned dragon with spines sticking out of their sides and large, sharp teeth. In fact, its whole group, known as the Rauisuchians, were truly outrageous, and many were a confusing blend of quadrupedal T-rex crocodiles that walked like dogs. Some had sails, others were thicker and more terrifying. All were predators. And yet, phytosaurs would have been their worst enemies, despite being smaller than the largest of the Rauisuchians. While old studies place phytosaurs as basal to the modern crocodilians, others now suggesting that they might have had something to do with the rise of the theropods too, perhaps having originated before reptiles split into what would become both crocodilians and birds. And all this happened around 150 million years before T-Rex even existed. To learn about more prehistoric oddities, check out our other videos through the links. And always, stay curious, fossil files.